Alright, so time for the solutions for the recursive and explicit functions paper. On each of these you have a sequence, and you need to get the common ratio or the common difference. You get the difference if it's arithmetic, you get the ratio if it's geometric, and then you write down the initial value. You use those pieces to get your recursive and explicit functions, and then you'll use your explicit function to get the 15th term. That's what a sub 15 means, the 15th term in the sequence. Okay, so let's start with these first two bits here. On my pattern here, it's add 3 each time. So my common difference is 3, because it's plus 3 each time. And the initial value is the first term in the sequence. That's 40. Okay, and we're using these two pieces to write our functions. And we're writing the two different types of functions. There's recursive, that starts with a sub n equals. Well, this pattern is adding 3 each time. So it takes the previous term and it adds 3. So any term in the sequence is equal to the previous term plus 3. And that's what the pattern is. When you're writing your recursive, you also need to write down what the starting value is, because this pattern doesn't tell you where to start. You could have started at 1 or 12 and still add 3 each time. But this one started at 40, so you have to put a sub 1, which means the first term, equals 40. And that's our recursive function. Time for the explicit one. These ones have the form of f of n equals, and then we're going to have n minus 1 in here, because we do have this pattern of the previous term plus 3, but we're not going to do plus 3 on this one. We're going to put 3 in front, and then we're going to add 40 on the end. Okay, and the reason we have this n minus 1 here is because if you were to plug in something like 1, as we want to know what the first term is, if you plug in 1 here, we'll get 0. 3 times 0 is 0, and plus 40. And so when you plug in your numbers of what term you want, you'll get the correct term, because we start at 40, and so we want this 3 part here to go to 0. Anyway, so here's our explicit function, and if we want to get the 15th term as an a sub 15, you just plug in 15 into your function. So f of 15 is equal to 3 times 15 minus 1 times 3 plus 40. Well, 15 minus 1 is 14, and when you times that by 3, you're going to get 42. So f of 15 is 42 plus 40, which is 82. So a sub 15 is going to be 82. And you're going to follow that same pattern on each of these problems. Get the difference of ratio, get the initial value, write your functions, and then get your 15th term using your explicit function. Okay? So we'll move on to the next one. The pattern on this one is times by -3. So we have a common ratio of -3. The initial value is -4, because that's the first term. We use those to write our recursive function here. So any term in the sequence is equal to the previous one times -3. And you have to put down the initial value. A sub 1 is equal to -4. And with this times 3 here, you could just put 3 in front, and that would have gotten you the same thing. So like 3 a sub n equals 3 a sub n minus 1, but this is fine too. Now we're going to write the explicit function. Start with f of n. And on these ones, this is a geometric sequence, so it's got a little bit different form. You got 2 terms here that you're going to use. The common ratio is going to go in this spot. Whoops. It's going to go right there. And then your initial value goes in front. Okay, -4. And you have to put this, the common ratio here in parentheses, and it has an exponent of n minus 1. So f of n is equal to -4 times -3 to the n minus 1 power. And that's going to be our explicit function. And that's in your notes. You're just basically plugging in the numbers where they go. And now we're going to use that to figure out what our 15th term is. So plug it in, you got negative 4 times negative 3 to the 15 minus 1 power. And when you calculate that, you're going to get a fairly large number. Please use a calculator. So I'm going to have 3 to the 14th power. Oh, negative 3 to the 14th power. Oh, hold on one second. Alright, yeah. So remember, negative 3 to the 14th power times by negative 4. You get a really large number. And that makes sense because here exponent is really, really large. It's 14. But you get a number that looks like this. 19,131,876. Negative. So that's our 15th term. And that happens a lot with the geometric ones. They grow really, really quickly.